They say to make an omelette, you gotta break a few eggs. Well, to ship a video game, you're gonna have to commit a few game dev crimes. What is a game development crime, you ask? Well, for the purposes of this video and hopefully catchy thumbnail, it's hacks, it's tricks, it's shortcuts that you take to get a game done. Generally just doing stuff that is absolutely not best practice. Are these federal level, straight to jail crimes? No, these are more like game dev equivalent of jaywalking, or using the self-checkout and saying that you only got the normal tomatoes instead of the fancy ones. Everyone does that, right? The thing is, doing everything by the book doesn't get games shipped, or at least not mine and not on time. And honestly, I think that the hacks, tricks, and shortcuts are some of the most fun things about game development. So let's look at my favorite crimes that I recently committed while finishing up my solo indie game, Feed the Deep. Let's start with a simple one. Have you ever seen the famous example from Super Mario where the bushes are actually just the clouds, but a different color? Well, the equivalent for Feed the Deep is that the silt texture is absolutely everywhere. If you're not careful while you're diving in the caves, you can disturb these areas of silt, which makes it hard to see and can conceal the enemies. I drew this silt texture in 5 seconds because it's just like a really basic texture and it didn't seem like it would matter. And then somehow this texture got used everywhere. Damage effects, those are silt, just colored differently. Moody intro scene, that's silt. The clouds in the credits, those are silt just stretched and resized. The texture just pops up absolutely everywhere because I guess it's a pretty generic texture, but hey, at least these effects have a texture. Some of the items don't have a texture assigned at all, or I just used a default circle and then prettied it up with animation or a shader. So let's talk about the enemy AI. In the game, there are these horrifying tentacle enemies that can move around in the underwater caves and attack you. To get them to be able to do things like, oh, I took a hit, I need to run away to a deep part of the cave, we decided to use Unity's inbuilt nav mesh system. Now, a nav mesh is basically a system where you can tell an agent, which can be anything, in this case enemies, to go somewhere in a maze and it will figure out the best path to get there. You might be wondering why we didn't do this a different way, why we didn't build something from scratch. And well, to answer that question, here is my programmer friend Chevy, who helped me with this system, to explain.
So normally, things move on a nav.
Wow, very interesting. Thank you, Chevy. So step one is to convert the level geometry into a nav mesh that the game engine can understand. And that's easy enough, but then this is where the hacks begin. Technically, the Unity nav mesh system is meant for 3D games. And while it can do a 2D nav mesh, it can only do it with the y-axis pointing up. So that means when we generate a nav mesh of the level, you can't actually see it. Like, I didn't think it was working, but then you can when you switch to 3D. Now, obviously we need the enemies to move around in the same plane as the game, and there's no way in the world I'm changing the whole game to be y-axis is up this late in the game. That would just be crazy. So to get around this, the nav agents do indeed move around in this Y is up nav mesh doing their thing, and then we just translate those coordinates back to the game so it matches. So the enemy itself, it has no idea where it is. It's just mapping its position to like this proxy agent mapped to like a parallel universe.
Parallel universes.
Is there a better way we could have done this? Almost certainly. But that's why this video is called Game Dev Crimes, or whatever name I picked. But we're not done with the enemies quite yet. You see, as the enemies cruise around, the most natural way for them to move is kind of like through the center of the narrow tunnels. Like they kind of look like they're feeling their way through, right? But then if there's one coming the other way, how do they squeeze past each other? It's actually possible for them to get stuck, and then more and more of them get stuck all in the one spot and they become like this tentacle monster rat king. So how are we going to fix this? Obviously we could figure out a way to make them turn around, we could get the avoidance working properly, but you know what's easier than any of that? Well, the game is dark, and 95% of the time you can't even see what the enemies are doing. So when you can't see them, we just turn off collision and they just cruise straight past each other, and it works totally fine. No one will ever know, except you who's watching this video, I guess. Speaking of the dark, the dynamic shadows are a big part of the game. They both define the look of it, but also make up a big part of the gameplay. And so now I've built this little test cave to demonstrate how all this works and why it's broken. Side note, I really like this little cave, like with the fixed camera. It's totally different feeling to like the massive caves you cruise around in the real game. So the lighting and the shadows are all done using the Unity Shadowcaster 2D system, which is pretty straightforward. You have these lights, and then you have these little 2D paths that define where the light should be blocked to create a shadow. But for the caves to block light in a way that looks correct, they need to self-shadow. That is, they can cast shadows onto themselves instead of just onto other objects. This is what it looks like with self-shadows off, and you can see it just looks all wrong. The shadows are only casting from the other side of the walls, like you can see into them. It just doesn't look right at all. And this is useful for things like the gold, where you kind of want to still be able to see that it's gold, but you want it to kind of cast shadows everywhere else. But the caves, they feel substantial, they feel big, they should be blocking light before it goes all the way through. But if we have self shadows on, we actually have a new problem. If we close in the top of the cave, now all of the light is inside this Shadowcaster and is blocked. The player, the items, and the water, it's all inside and no light gets cast at all, so we can't see anything. If I zoom out, you can see the system is working fine. Everywhere outside is fine, but inside is completely pitch black. So to make it look and work like the way you would expect for this game, the water and the light needs to be on the outside of the Shadowcaster path. So the way I solved this in the prototype was to not solve it, I guess. I just always had an opening at the top of the cave above the water line, and then that way it's a big U shape. Nothing's ever fully closed in. But as I moved on from the prototype and the game got bigger and better, I started adding like branching paths and connected caves and these really deep caves, and I just had to close it off. So I needed a new solution. So how do we create a Shadowcaster that solves all of these problems? Well, it turns out it's quite easy. It's just like the prototype. We just have to get our hands a bit dirty and be a little bit hacky. So first up, we figure out all of the Shadowcaster shapes based on the collision, just like before. Next up, we do a test on all of the Shadowcasters and find which two of them have the player inside. This gives us the main body of the cave, the area that we're going to be swimming around in, and in a closed system, we should be inside exactly two of them. If we're not, then we have problems. And next we find a point at the bottom of the cave, just anywhere, where those two Shadowcasters that contain the player are really nice and close together. And we split them and then connect their paths at the split into like one giant path. So this way the Shadowcaster, it's like the big U shape, right? Except I guess this time it's an N. And technically it's a big open shape, but just like where it's open is smaller than a pixel, so none of the light escapes. And so now we are on the outside of the shape, but like contained by it. So the shadows completely surround us, but the light is still able to like project and cast and everything works fine. If you happen to know exactly where this split is and you get into the exact right spot and you have the exact right item in the exact right spot, then yes, technically, sometimes you can get a tiny pixel of light. But that's it, it works perfectly. Speaking of the cave, what happens if the player gets trapped in the cave collision? If they get pushed through the walls onto the other side? Now look, this should never happen over the course of like months of testing. I've seen it happen twice, and so it's really exceedingly rare. The two ways it can happen is either the player triggers a spawn of a lot of objects in exactly the wrong spot, and realistically this only can happen if you pick like the Rock Slide Cursed perk from a mystery chest, so already it's very like improbable. Or the other way is if you happen to be in exactly the wrong spot when the tile map regenerates, when the bomb destroys part of the terrain. During the regeneration, some tiles change and randomize, and so it is just possible to be in exactly the wrong spot for a single frame. I spent some time mitigating these issues, but you could never 100% guarantee that it would never happen, and I just wanted to make sure there was a backup plan in place. Because if it does happen, it basically ends your run. You're stuck on the wrong side forever. Luckily, there is an easy way to see if you're trapped inside a collision. We can simply fire a ray upwards and then count how many times it intersects with the cave. If it is an even number of times, then we're all good, no issues, we're inside the cave where we should be. But if it's an odd number of times, it means we're trapped. To untrap ourselves, we can simply teleport the player up to just above the closest odd numbered intersection point. Wait, isn't that just the first intersection? Anyway, we can just teleport the player to just above the first intersection point, and this puts us back into the cave, because then we now are at an even number of intersections. Except it's not quite that easy, is it? My original thought was to just use array, and we just count how many times it crosses the path of the collision of the cave. But in the Unity Physics 2D package, the ray will stop when it collides. So what we need to do instead is iteratively work our way up. We fire the ray up, when it collides, we count, and then we start a new ray at the same point. Except it's not quite that easy, is it? Because if we start at exactly the same point, then we will just instantly collide at the exact same point again. We'll never get anywhere. So we need to jump up just like the tiniest amount so we clear the line and the ray can continue up and find the next intersection. Except it's not quite that easy, is it? Because if we jump the ray up, then if we happen to have collided at just the very tiniest tip of a corner, then we might jump to the other side. And now, instead of having 2 collisions, it mistakenly thinks we've only had 1. And I mean, we could make that jump smaller, but now all we've done is like reduce the chance of that happening, but it could still happen because we could get down to it like essentially an infinitely small point if it's right on the tip of a corner. This can happen kind of more often than you would think because the cave walls are kind of gnarly and jagged, so we can actually have like dozens of intersections as the ray is fired up along a wall. So if the game thinks, oh crap, I think I might be stuck inside, there's an odd number of intersections, then all I do is do the test again, but from a slightly different place, and then again, and then again. And if any of them return an even number, then the game is like, no need to worry, we're fine. False positive, we're all good. This is totally just a brute force approach, but it hasn't failed me yet. It seems to work great. Although I do feel like somehow, like some crazy speedrunner might find some exact right place to stand and then they can like kind of glitch in and they can be right at the top and escape the level or something. That's going to be awesome. I hope someone does that. And look, you might have watched all this so far and gone, hey Luke, these aren't even really hacks. This is more just like game developer getting stuff done stuff. And I guess that's true, that's fair. A lot of the true hacks are more programming specific. And if we want to get really specific, they're just like bad programming. Just really dodgy bad stuff that I've done. And I was kind of like, I don't know if those are going to be as entertaining to watch because the Luke didn't program something right joke kind of gets old pretty quick. But here's a few of them really quickly. So we're dragging the chum down to the deep. How does the deep know that the chum has like gone close to its mouth? Well, we just test everything that enters the collision around the deep's mouth. And does that object have the word chum in it? Well, I guess it must be the chum. Just never ever accidentally like name anything chum or have the word chum in it, and it'll be fine. How do we know where it is safe to spawn larger items? Let's do a big, wild, like for if statement, just cycling through all of the tiles in the level, looking for the right pattern. And then we look at that and we go, God, this is absolutely horrible. I can't stand to look at it. So you just bump it all the way down to the bottom of the file. You make a cute little ASCII hack house. And then all of a sudden, like it feels quite cute. Like, look at it. It's in its own little house. Let's not disturb it. Let's never change it or fix it. And it can just be there and live there forever. How do we deal with setting up a massive scene with hundreds of items that are all connected together when we load from a save file in a totally different order to how the level was generated? We break it up into a bunch of steps, slightly delay some stuff to make it happen in the right order, realize it doesn't work, move some things around, and keep doing that until it magically works, and then never look at it ever again. I don't really know how it works, but it does. At the end of the day, it's kind of a miracle that this game, or really any game, because let's be real, all games work like this, works at all. The whole thing is a house of cards, supported by a separate house of cards built on an engine that is its own house of cards. The good thing, at least, is when you're a solo developer, you can bend and break the rules a lot more, because it's not like someone else is going to come in and look at your code and, oh yeah, Chevy. And I know there are better ways to do this. I'm sure a bunch of people are going to tell me in the comments. I would love to hear it, because I know there's people smarter than me watching this video, and you can be like, hey, did you know blank? But I'm not changing any of this, because guess what? It's too late. The game is done. It's not in development anymore. And I've been testing it like 6 hours a day for a few weeks. And you know what? It all works, and it's actually pretty bloody good. I am proud of this game. It's actually really stable. Everything works really good. I guess there's enough layers of duct tape on this bad boy to like keep it pretty solid. It works great on pretty much everything. It seems like it works really good on a deck. And the game comes out really soon. August 16th is the date. August 16th is the date. Why can't I say August 16th is the... It comes out August 16th. If you're watching this video before then, you should go wishlist it right away. Wishlisting like really helps. It helps give it like a big bump when the game first comes out. But if you're watching after that, you don't need to wait at all. You can go buy and play it now. And there's so many cool things that I'm excited for players to find. There's been lots of little like touches and stuff that I've tucked away, and it's going to be really good, I think. And although the game is pretty much done, there is going to be a couple more videos about it. I'll definitely do a post-mortem on the game, go through the things that went right, the things that went wrong, because there's definitely a few things behind the scenes that have been super frustrating and, you know, have been really difficult to contend with. And let me know if there's anything in particular you'd like for that video. And then there's so much more stuff that I'm going to be doing. Eventually, I'll get to start working on something new, and the new thing that I'm going to be making next is sick. I'm like really excited. So yeah, I think that is everything. This is about the friggin' 4th time I've recorded this video, because things just keep going wrong. So hopefully this video turned out okay, and that's it. This is the part where I kind of ramble on a bit, because I can put up like the playlists and the subscribe and all that. But I promise I'm done now. Thanks for watching. Bye.